This is the topic 1 video for graphing solving systems of equations. So we're going to learn 3 methods this unit, and the first method that we're going to learn is graphing, which is really, most of it is nothing new. So we do know how to graph lines in different forms, so we're going to start by graphing both lines. So if we look, our first line that we see is 2x plus y equals 4. Since this is in standard form, I'm going to graph this line by using an intercept table and the cover-up method. So if I plug in 0 for x, I get y is equal to 4. And if I plug in 0 for y, and I divide both sides by 2, 4 divided by 2 gives me x equals 2. So if I plot both of those points and connect them, here is my first line. And I'm going to do the same exact thing for the second line. This time I'm going to graph it in blue. It is also in standard form, so I'm going to use an intercept table for this one as well. Plugging in 0 for x, I need to divide both sides by -1, which gives me -2 for my y value. When I plug in 0 for y, I don't have to do anything. X is equal to 2. Then I'm going to plot both of these points and connect them with a line. So when we have a system of equations, the solution is where they intersect. So we have 3 different outcomes, and our first outcome is when we have an intersection point and an ordered pair x, y. All right, so the ordered pair of this intersection point is 2, 0, where the 2 lines cross. So that's one outcome. We're going to have 2 other outcomes that are possible. So let's take a look at one of those. Our next example, we're going to start the exact same. We're going to graph each line. Now this first line is in slope-intercept form, so I don't have to use an intercept table. I can start at -3 and apply the slope of +2. A good tip/trick for this topic is to plot as many points as possible, because if you're looking for an intersection point, you want it to be super accurate. So especially if you don't have a ruler at home or a straight edge, you're going to want to plot as many points as you possibly can so we can clearly see where these lines intersect. So here's my first line. Now let's start our second line. This one is in standard form, so I'm going to use an intercept table for this problem. If I plug in 0 for x, I solve for y and I get 1. When I solve for x, plugging in 0 for y, dividing both sides by -2, I get -1/2, which we're not used to, but that's okay because we can just estimate where it is. So 0, 1 is plotted. Here's -1/2, 0. Now when I connect these points, something interesting happens. We're looking for the intersection, but in this case, we have parallel lines. So the second outcome out of 3 possible outcomes is if we have parallel lines which never intersect. So that means our answer is no solution. There's no intersection point, no solution. All right, our third type of outcome we're going to see with this problem. So let's start by graphing our first line. So for our first line, we have a y-intercept of +2 and a slope of -2. So we can make that line. Now my second line is in standard form, so let's make an intercept table and plug in 0 for x. Solve for y, we get +2 by dividing both sides by 3. And then plug in 0 for y, divide both sides by 6, we get x is equal to 1. However, when we plot 0, 2, that's on the other line, and when we plot 1, 0, it's also the other line. So when we connect these 2 points, we get the same line. So this is our third type of outcome, which results in something we call IMS, which stands for infinitely many solutions. So if we ever get the same line, that means our answer, we can write IMS, since no one wants to write infinitely many solutions out a bunch of times. What this means is every single point on that line is a solution, and there's infinitely many points on a line, so that means there's infinitely many solutions. Now we need to make sure we don't get this confused with all real numbers, because if it were all real numbers, then that means this point would be a solution, or this point would be a solution, which is not the case. So IMS is not the same as all real numbers. No, no, no. All right, please do the 2 U-try problems on the next slide, and that will conclude your video notes for this topic. Thank you for listening.